Hi friends, now we are going to discuss about types of DC machines. So, in DC machines, based on the basic principle, it is classified as DC generator as well as DC motor. In DC generator, if we use it permanent magnets, it will come under permanent magnet type. Or if we go for a electromagnets for producing the magnetic field, it will come under field excitation, nothing but electromagnetic type. So, in electromagnetic type field excitation, again it is classified as separately excited and self excited. This is because if the field winding is excited by a separate device, separate DC input, then it comes under separately excited system. If the excitation is done by the same device, nothing but our armature arrangement, armature, field winding, and the load, these are all connected together without any external supply. That means the excitation is done in the system without any external device is considered as self-excited. And again this self-excited is further divided into series generator, shunt generator and compound generator. Now we shall discuss all these types in detail. Coming to this separately excited DC generator. These are the generators whose field magnets, I'm repeating, whose field magnets are energized by some external DC source such as battery. If the field winding is excited by a separate external source, then it comes under separately excited DC generator. In this, as if you observe the figure, IA is nothing but the armature current and IL is nothing but the load current, and V is the terminal voltage and EG is the generated EMF, and voltage drop in the armature is nothing but IARA and RA is nothing but the armature resistance. And let us say that IA is equals to IL is equals to I, then the voltage across the load will be V is equals to, from the Ohm's law, I into RA. Thereby the power generated is considered as P suffix G, that will be equals to the EMF generated at the armature, EG into I. Coming to the self-excited DC generator, these are the generators whose field magnets are energized by the current supplied by themselves. In these type of machines, the field coils are internally connected with the armature. In this, the field coils are internally connected with the armature. Due to residual magnetism, some flux is always present in the poles, and when the armature is rotated, some EMF is induced, hence some induced current is produced. This small current flows through the field coil as well as the load, and thereby the strengthening the pole flux. As the pole flux is strengthened, it will produce more armature EMF, which causes further increase of current through the field. This increased field current further raises the armature EMF, and this cumulative phenomena continues until the excitation reaches to the rated value. According to this position of the field coil, the DC generator has three types: series generator, shunt generator, and compound generator. Coming to the series generator, in this type of generators, the field windings are connected in series with the armature conductors. So, whole current flows through the field coils as well as the load. As a series field winding carries full load current, it is designed with relatively few turns of the coil. The electrical resistance of series field winding is therefore very low, and that is nearly 0.5 ohms. And let RSC be the series winding resistance, ISC is the current flowing through the series field, and RA is the armature resistance, and IA is the armature current, and IL is the load current, V is the terminal voltage across the load, and EG is the generated EMF. And then as it is a series, the current will be same throughout the circuit, thereby the armature current will be equals to the series field current, and the series field current will be equals to the load current, and therefore we are considering it as I. Let it be I. And the voltage across the load V will be equals to EC minus IARA, and the power generated PG will be equals to EG into I. Therefore, the power delivered to the load, that is PL, will be equals to V into I. It's a very simple process. Once if we design the circuit, in that circuit firstly we have to concentrate on the currents what are the currents traveling through the armature, through the field winding and load. And thereafter we have to focus on the voltage equation, and thereafter we have to concentrate on power generated as well as power delivered. Okay, coming to the shunt generator. In this type of generators, the field windings are connected in parallel with the armature conductors. The field windings are connected in parallel, hence the name suggested as shunt generator. In shunt generators, the voltage in the field winding is same as the voltage across the terminal. Here armature current IA is dividing in two parts. One is shunt field current ISH and another is the load current IL. So IA will be equals to ISH plus IL. The effective power across the load will be maximum when load current will be maximum. So it is required to keep shunt field current as small as possible. For this purpose, the resistance of the shunt field winding generally kept high, 100 ohms, and large number of turns are used for the desired EMF. Let RSH is the shunt winding resistance and ISH is the current flowing through the shunt field, and RA is the armature resistance and I is the armature current, and IL is the load current, where V is the terminal voltage and E is the generated EMF. And the shunt field current ISH will be equals to V by RSH. Voltage across the load V will be equals to EZ minus IARA, and the power generated PG will be equals to EZ into IA, and the power delivered to the load will be equals to V into IL. And we have to purely concentrate on one particular thing, that is nothing but the current. The IA will be equals to IL plus ISH, whereas in series all those three are same. IA will be equals to IL will be equals to ISC, and we have considered it as I. Okay, whereas coming to shunt, the current will be divided, that is nothing but IA will be equals to IL plus ISH. Okay, next, compound DC generator. In series wound generators, the output voltage is directly proportional with load current. In shunt wound generators, output voltage is inversely proportional with load current. A combination of these two types of generators can overcome the disadvantages of both. Hence, this combination of windings is called compound wound DC generator. These compound wound generators have both series field winding and shunt field winding. One winding is placed in series with the armature and the other is placed in parallel with the armature. And again it is classified into two types, that is short shunt and the long shunt. It is purely depending upon the field winding where it had connected. If it is connected across the armature, it is considered as the short shunt. If that field winding is connected across the load, then it is considered as the long shunt. We can see it. This short shunt DC compound generator, the generators in which only shunt field winding is in parallel with the armatures, can be observed in this figure. That is series field current ISC will be equals to IL, and the shunt field current ISH will be equals to that voltage by resistance, and that voltage is nothing but V plus ISC into RSC, and the armature current IA will be equals to ISH plus IL. Next, after considering all these currents, we have to focus on the voltage equation. The voltage equation V will be equals to the generated EMF minus IARA minus ISC into RSC. This can be obtained by using the KVL. Next, the power generated PG will be equals to EZ into IA, and the power delivered to the load will be equals to V into I. Coming to this long shunt compound DC generator, the generators in which the shunt field winding is in parallel with both series field and armature windings, nothing but it is connected across the load. If you observe the figure, you can easily observe it. It is connected to load and it is connected parallel to the series field and armature. The shunt field current ISH will be equals to V by RSH, and the armature current IA will be equals to series field current. Hence, ISC will be equals to IL plus ISH. Voltage across the load V will be equals to EZ minus IARA minus ISC into RSC. And if you observe, that will be equals to EZ minus IA of RA plus RSC, since the armature current will be equals to the series current. and the power generated Pg will be equals to Ec into Iu, and the power delivered to the load will be nothing but V into IL. PL, that is equals to V into IL. In a compound generator, the shunt field is stronger than the series field. When the series field assists the shunt field, the generator is said to be commutatively compound generator. On the other hand, if the series field opposes the shunt field, the generator is said to be differentially compound generator. And thank you.